In this video, I'm going to try to answer the question, what is big data? This presentation is based on one that was originally created for an event called Demystifying Big Data at the University of Edinburgh. So it's slightly less formal than some of the lectures on the course, but it does provide a little bit of background and a nice introduction to what big data is. So I'm presenting it here. So let's start by trying to answer this question. This is what the lecture is really all about. What is big data? And of course, the first answer is that big data is a buzzword. We can't get around that. It means different things to different people. It hasn't really got one formal academic description of what big data is. So it does mean different things to different people, and we can't get around the fact that there is a bandwagon, there is a big data bandwagon, and lots of people are trying to jump onto it. However, we do believe there is some substance behind the hype, and that is the reason why we're telling you about big data. And of course, big data is an important part of data science. So what I'm going to try and do in this presentation is to pick out some of the useful stuff from all the hype. I'm going to try to explain the different aspects of big data and what it is about big data that makes it different from small data. This is important, of course, because data is everywhere and we're all using it. I'm using data in the singular here, a little footnote as to why this might not be as incorrect as you might initially think. I probably switch between the singular and the plural on this course, so apologies in advance for the inconsistency, but as I think you can see that it's widely used in both senses. Anyway, big data is everywhere, but one person's big is just another person's normal. So can we measure big in terms of bytes? That's probably not enough. So in the next few slides, I'm going to try to work out what it is that makes data big data. And this is a pretty good starting definition. So this is the one that I'm going to use. And it's based on this idea of the 3 V's of big data. So this is a widely used description of what makes data big data. And the idea is that data is big data if it's too big in some dimension, where that dimension is either volume, velocity, or variety to work with in the ways that we've been used to. So this is a pretty broad definition. It's quite good because it's about how we work with big data. It is, of course, flawed because the ways that we've been used to is a moving target. And as we become used to certain big data techniques, does that mean it's not big data anymore? Well, possibly, but it's still probably different from the way we did data in the past. So maybe at that point we'll have some better names for it. But in the meantime, we can use this definition that data is big data if it's too big in volume or velocity or variety to work with in the ways that we've been used to. So let's have a look at these 3 V's of big data. So these were the original 3 V's of big data, but of course, as soon as somebody had 3 V's, somebody wanted to add a new one, and very quickly a 4th V came on the scene. I actually quite like this V because it's the flip side of the coin. It's the idea that big data has value. So whereas the ones on the left-hand side, volume, velocity, and variety, tend to be about the problems that we have to deal with when we're dealing with big data. The reason that we're doing all of this, the reason that big data is useful and why we bother to process it all in the first place is because that it has some underlying value. There are things that we could do once we start looking at large amounts of data that we couldn't do before. The trouble was, as soon as somebody invented a 4th V, everyone jumped on the bandwagon. And before you knew it, there were 6, 7, 8 V's. People keep on adding them. And what I'm going to do now is to try to explain what all these V's are, and say those that I think are important. Actually, they probably all are different aspects of big data. The ones in orange here are maybe less about the definition and more about issues associated with big data, but it's still interesting to think about what all these things are about. And it's still interesting to think about why these are different in the case of big data from normal data. So let's start with volume then. Volume is just the idea that there are now too many bytes or too many files or too many records to work with in the usual way. So that might be to fit in cache, to fit in memory, to fit on disk, or even to store at one site, depending on how big your volume is. So, of course, different people have different problems with volume, depending on what they've been trying to do. It's now getting to the stage where this problems not fitting in memory means that you have to think about different ways to process the data. But also we have these bigger problems that data is now too big to fit on a single disk or even to store at one site. And then we have to think about ways to work with data in a distributed way. And this is one of the implications of working with such large volume of data. The next V is velocity. And this is about the fact that data is arriving either too quickly to be processed or too quickly to be analyzed, or possibly that data needs to be available very quickly. So this latter point, for example, is one thing that high performance computing might be able to help you with, large supercomputers that can crunch the numbers very quickly in order for you to get an output in a short amount of time. You also might be able to do this with a distributed architecture, a scale out type architecture, a cloud like solution, in order to be able to get your answer in real time. So the velocity is an important one. It's not just about the size of the data, it's about how quickly that it's coming at you. The third V is variety, and this is about the fact that data is now too varied, and by this we normally mean unstructured. So it's too unstructured to store in a traditional relational database, for example, or to process with traditional tools. It's partly about the fact that whereas in the past we might have been working with files full of numbers or characters or some kind of simple tabular data, we're now working with all sorts of content types, whether that's images, sensor data, video, sound, tweets, whatever. It's quite astonishing now that if you think even of a typical smartphone, the number of different kinds of data that it's collecting or that it could potentially collect at any moment is huge. A typical smartphone might have 2 cameras, 3 or 4 radios, a touch screen with a sensor, an accelerometer, multi-axis. It might also have some kind of gyroscope in it. Microphones, typically several microphones. And all of these are creating different kinds of data. So this is the kind of data now that if we look at it together, we can do the kind of things that we couldn't do before in terms of interpreting this data by joining it together. And this is the variety aspect of big data. The fourth one then, as I mentioned before, value. This is the reason that people are doing big data. Okay, so the large amount of data that we have available means that we can do things now that we couldn't do before, and that's important. So we are by having all this existing data that's out there, it means that we can do science, we can do research, we can do analysis in different ways from the ways we could work before.